In the next 4 videos, we're going to talk about some background we need for Project 1. In Project 1, you're going to build a robotics map using LIDAR data. In this video, we're going to talk about Euclidean space and vector. The learning objectives are knowing Euclidean space and Cartesian coordinate system and Euclidean vector. The outcomes are understanding 1, 2, and 3-dimensional Euclidean spaces, Cartesian coordinate system with its origin, and how to represent a vector in R3. Euclidean space is the fundamental space of classical geometry. Ancient Greek geometers introduced this space for modeling the physical universe. In 3D, we can construct the Euclidean space by using 3 perpendicular planes. The intersection of 3 planes will give us the origin. Now, any point in this space can be uniquely identified by 3 parameters, x, y, and z. We have 3 perpendicular axes, x, y, and z. The parameter x shows the distance from the origin along the x-axis. The parameter y shows the distance from the origin along the y-axis. And parameter z shows the distance from the origin along the z-axis. Therefore, the point is uniquely identified in the space. The collection of all these points will construct the 3D space, as we will see later. First, let's look into the one-dimensional Euclidean space. The one-dimensional Euclidean space is simply the real line, the line whose points are the real numbers. And in Julia, we can define a point using a real number by simply assigning a number to a variable. The two-dimensional Euclidean space is a set of pairs of real numbers. Mathematically, we can show it using this set and call it R2. We can build the 2D Euclidean space using 2 real lines, and the intersection of these 2 lines will give us the origin. Notice that 2 lines are perpendicular. Any point in this space can be identified using 2 real numbers. The first coordinate is the distance from the origin along the x-axis, which is 2 for this point. And the second coordinate is the distance along the y-axis from the origin. In Julia, we can define a 2D point using a 2 vector. The 3D Euclidean space serves as a spatial model of the physical universe, in which all known matter exists. We can define any point, such as P, using 3 parameters x, y, z, which shows the distance from the origin along their corresponding axis. And we can define 3D points using 3 vectors in Julia. A Euclidean vector, or simply a vector, is a geometric object that has magnitude, or length, and direction. A vector pointing from A to B, here called vector A, has the initial point A and the terminal point B. this vector is what we need to carry point A to point B. In this example, we see a 2D vector in the Cartesian plane showing the position of point A. The initial point is the origin, and the terminal point is point A. Finally, we're going to see how to represent a vector in the 3D space. Recall that we have three independent axes, x, y, and z. We define unit vectors I, j, and k. I is the unit vector along the x-axis, j is the unit vector along the y-axis, and k is the unit vector along the z-axis. Notice that we call them a unit vector because they have length 1. A 3D vector, such as ax, ay, and z, has 3 coordinates. We can write A to be the product of each parameter along its unit vector. In other words, I, j, and k are the direction, and ax, ay, and z are the magnitude. And using these 3 coordinates, we can uniquely move from the origin to point that is the terminal point of our vector. In the next video, we're going to see linear transformations.